Hello students and welcome to Solving Absolute Value Equations. This is on the back of the transformations notes, and there is also a second page with yet another thing on the back of that. So, sorry about that. So first consider this. If the absolute value of x is 5, what are some things that x could be? So that means if my distance to a number from 0 is 5, then what could the number be? Well, the number could be 5. 1, 2, 3, 4, 5. 1, 2, 4, 5, or negative 5. So the number could be 5 or negative 5 because the absolute value of 5 is 5, and also the absolute value of negative 5 is 5. So absolute value equations can have two different solutions, just like this one did, 5 or negative 5. It could have only one solution, or it could have no solutions at all. So here's what I mean. Let's try a few. So try solving these. The absolute value of x equals 3. So kind of like the one above, if my distance from 0 is 3, then my number could be 3 or negative 3, because they're both the same distance from 0. So x could equal 3, or x could equal negative 3. And when it's the same number like that, they're opposites, you might see it written that way. So that's a plus minus. It's a plus with a minus sign underneath it. So that's just what that means. So this one had two solutions. What about this one? Well, if my distance from 0 is 1.5, I could again have positive 1.5 or negative 1.5. So x equals 1.5 or x equals negative 1.5. And again, you might see it written like this. X equals positive plus minus 1.5. Example 3. If the absolute value of x equals 0, what could x be? Well, the only number that is exactly on 0, no distance, is 0 itself. So x has to be 0. So we've seen already functions with two solutions, functions with one solution. Now we're going to see a function with no solutions. So if the absolute value of x is negative 7, what is x? So remember that the absolute value parent function lies completely above the x-axis, and the range was all non-negative numbers, so 0 and up. That means I can't have an absolute value equals negative. If I talk about distance, my distances are never negative. Distances are always positive. So that means this is no solution. So absolute values cannot be negative. And we'll get down to a summary here in just a second. Same one here. If the absolute value of x is negative 2, there's no number that does that, because if I take the absolute value of a number, I'm going to get a positive number. So this has no solution. And this thing that I'm drawing here is 0 with a slash through it. That just means no solution. Just another way to say that. You wouldn't have to write both. You could pick one or the other. And finally, example 6. Go ahead and try it yourself, and then check your answer. So you should have gotten x equals 2/5, or x equals negative 2/5, or you could have written it like this. So let's summarize. You will have two solutions if your equation looks like this. So if you have absolute value of x or absolute value of really anything in there, and it equals a positive number, you're going to have two different solutions. On the other hand, you'll have only one solution if your equation looks like this. So absolute value of something equals 0. And then finally, you'll have no solutions at all if your equation looks like this. So absolute value of x equals a negative number. So let's try example 7. So example 7 is a little bit more complicated because instead of just having an x in the absolute value, I've got something else in there. So if you remember the video on inverses, I talked about solving using reverse Pemdas. And we're going to be doing that a lot this year. Almost anytime we solve an equation in this class, we're going to be doing PEMDAS in reverse. That means that I first look for any addition or subtraction that is outside my parentheses or whatever symbol I have. In this case, the absolute value are your parentheses. So do I have anything I could add or subtract that is outside this absolute value? Well, not really. I could subtract a 3 from both sides or something, but it's not going to help me out because I want the x by itself. I want to get stuff away from here. So there's really nothing I can do there. Then I move up to multiplication and division. Is there anything outside the absolute value, because I haven't reached that step yet, that I could multiply or divide away? And again, the answer is no. There's really nothing that's going to help us there, so I don't need to do that step. Then e is exponent, and I don't have any exponents in here, so just cross that one out. Finally, we get to the parentheses step. When you get to the parentheses step for absolute value, you are going to split your equation in two, and this is how you do it. You can draw, I like to draw arrows, but you don't have to draw arrows. But you're going to take the part that's in the absolute value, so x minus 1, and then I know that when I take absolute value, it could have been positive 3, or it could have been negative 3. So kind of like we did right there. This was absolute value of x equals 3, so I split it into 3 and negative 3. I'm doing the same thing here. I split it into 3 and negative 3, except now I also have a minus 1 on the left side that I didn't have before. You know what? That's easy enough to fix, because now that we're done with this step, we go back to the bottom. Is there anything on this side that I can add or subtract? Well, sure, I can add a 1 to both sides to cancel this out, and then do it to this one too. So then x equals 4, or x equals negative 2, and then I'm done. So I go to the next page, and we have a couple more examples. And we're going to be using reverse PEMDAS again. So use the order of operations, PEMDAS, in reverse to isolate the absolute value. So let's do that. So let me write, I'm not writing here. And I'm solving this equation, the absolute value of 3x plus 2 equals 8. So first, I'm going to start at the bottom because I'm doing PEMDAS in reverse. Is there anything that I can add or subtract outside the absolute value, which are my parentheses in this case? Well, yeah, I could subtract a 2 from both sides, so let's do that. And what that does for me, it gets me one step closer to having this x all alone. Next, multiply or divide anything outside the absolute value. So I've done add subtract, now I'm on multiply and divide. Now I have multiplication division, but it's inside the absolute value, so I can't do it yet. I have to take care of the split first. Cross that out. And again, the exponent step we're not going to use for this function because there are no exponents. So let me carry that down. Okay, so now we're at step 3. Now you have the absolute value isolated, and we do. The absolute value is all by itself. So split the equation as long as the right side is non-negative. So just check over here. Remember this business. If ever my absolute value equaled a negative number, I would have no solution, so there's no need to go through all those steps. But in this case, I have a positive number, so I know, since I have a positive number, I know I'm going to have 2 solutions, so I might as well continue solving. So let me just rewrite this here again. Okay, so I've rewritten what I have, and I'm going to split it. So I have 3x equals 6, and then 3x equals negative 6. So again, that's just like I did here. My absolute value, and then 3 and negative 3, I'm doing the same thing here. So the part in the absolute value stays the same. That's a pretty common mistake. The part in absolute value stays the same. Some people try to make this positive and negative, and it's not that you can't, but you have to do it properly, and that tends to not happen. So just make this positive and negative. So now I have two little equations to solve. So I'm now in the parentheses step. So let me rewrite Pemdas. I took care of the split. I did that. Now I go back to the bottom. Is there anything I can add or subtract to get the x by itself? And the answer is no, because I have multiplication here. So then come back to step 5. So let me rewrite this stuff. 3x equals 6. 3x equals negative 6. Now multiply or divide anything. So multiply or divide is the step we're on. So if I have 3 times x, I can cancel that by dividing by 3. And so I get x equals 6 divided by 3 is 2, or x equals negative 6 divided by 3 is negative 2. And remember, I can write this as x equals plus minus 2. Just like that. So it says try solving these yourself, but you know what? Actually, I'm going to go ahead and try number 8 right now, and then come back and check it. So this is what you should have gotten on number 8. So I split first because there was nothing to... I didn't write my PEMDAS. I went ahead and split it because there was nothing to add, subtract, multiply, or divide outside the absolute value, and there's no exponents at all. So I split it, and then I subtracted 7 from both sides of both equations, and I got that x equals 3, or x equals negative 17. Now number 9, I'm going to go ahead and walk you through because I know the fraction is going to freak some of you out. So go ahead and draw PEMDAS. Where are we doing PEMDAS in reverse? So start by adding or subtracting anything outside the absolute value, which is your parentheses in this case. And there's nothing. There's a divide by 3, and that's it. So now multiply or divide anything outside the absolute value. So I can cancel divided by 3 by timesing by 3. So then I get absolute value of x minus 1 equals 12 times 3 is 36. So that's done. There's no exponents. And now we're finally in the parentheses step. So for absolute value, that means split the problem. So x minus 1 equals 36, and x minus 1 equals negative 36. So add 1 to both sides of both equations, cancel that. So then x equals 37, or x equals negative 35. And there's your two solutions. Okay, now I want you to pause, or actually the video is going to pause in a second, so that you can try 10. I want to see if you can catch the trick that happens on 10. So give that a... So here's example 10 for you. So I started by adding or subtracting. I subtracted 2 from both sides. Then I multiplied and divided, so I divided by 3. And then when I got the absolute value by itself, I realized that my absolute value equals a negative number, and we can't have that for absolute value. Remember, if your absolute value equals a negative number, you have no solution. So that means I didn't really have to finish the problem anymore because I knew I was going to end up with no solution.